Thank you. Okay, so can you hear me, everyone in the back? That's perfect. So thank you all for attending this talk. I know there are other talks, very interesting talks as well. So I really appreciate you being here and being interested for this topic. So let's start. We have a couple of demos and things to talk about. This disclaimer for the different products that we are going to mention and everything, so it's always in our presentations. This is who I am. I'm JP. My name is actually longer. It's Juan Pablo Pérez Echegoyen, but better JP is much more convenient. I work at OWASP. We are focused on business critical application security, very focused on SAP applications, but also covering Oracle applications as well. So we do all different sort of things around that, like pen test, develop products, trainings, talks like this one. So as for my background, I have been presenting and holding trainings on different conferences, such as the one you can see in the presentation. And I have been doing research on SAP since long time, reporting vulnerabilities to SAP, and to Oracle as well, many vulnerabilities for JD Edwards and other Oracle products as well. So my background is from the technical part, from doing pen tests, doing research, and that's what I use to present in security conferences. So this is what we are going to talk about, in-memory platforms. I'm going to introduce you to the in-memory platforms and in-memory databases. We're going to talk about a specific product that is called HANA. How many of you know what SAP is? How many of you know what HANA is? Okay, it's you're going to learn a lot of new concepts. We're going to be talking about threats or attack vectors to these products because of this special architecture or different approach to web applications that is shipped with SAP HANA. We're going to talk about different threats, and we're going to draw some conclusions, and hope you take this out of the presentation. So I was thinking about doing a slide to introduce you to in-memory platforms and in-memory databases, but then I realized that it's actually a really simple concept, right? It's a database that is running in memory. It's not a database that doesn't require storage, like it still requires a lot of storage, but it requires a lot of memory to be able to run. To be able to access a table, to be able to operate on a table, to do selects, updates, to actually work with the data, you need a lot of memory, right? So you need to be able to put all that table within memory, so we're talking about terabytes of memory. And I copied this because I think it's quite interesting from Gartner itself, talking about that in-memory computer will be one of the top 10 technologies of 2012. And actually, it's being pushed very hard from the different vendors that we will see. But it's really something that is growing and getting a lot of attention. So how come it's not already implemented within companies? Like, how come that companies are not actually using in-memory databases within their business critical applications or all their applications? And there are some reasons that are actually helping on the evolution of this. You all know about this: memory costs going down, data requirements increasing, system responses requirements are getting higher and higher, right? So we have applications that are being used within companies, for example, to do business intelligence. So if we have a report that used to be generated in 30 minutes, but now can be generated in 30 seconds, that's something very powerful, and that's something very important to have near real-time visibility on what's going on within the business. So that's one of the biggest selling approaches of this technology, right? And then it's about innovation. We have companies that are actually releasing this year their database products using in-memory technology, right? So we have companies such as SAP that have HANA, which is which has been implemented since 2011, so it's been in the market already. But we have companies such as Oracle that are right now releasing new products with this technology. So it's getting more and more traction and more attention. So for this, I would like to show you some quotes which I think are very enlightening to actually get the picture of what we're talking about. So this is from Oracle, talking about their new product, which is Oracle 12c. It's orders of magnitude faster, like the difference between walking and flying. And that's what we're talking about. We're talking about speed. We're talking about response, system response, systems being able to produce information in near real-time times, right? Then we're talking about innovation, another quote from SAP. And this one, I think it's very important to actually understand what we are going to be talking about, which is the traditional approach, having the application, the users at the application level, at the web application level, and the database in another layer. And I think this picture is very good because it's showing you how the application is actually moved down to the same layer as the database, and the user is brought down to that layer, and the response, because of that, is completely different. And then there's something else that I don't personally like this, but this is something for you to have an idea of the kind of push that is having this from the vendors. This is one product that is pushed from SAP, actually using HANA. SAP is generating a lot of products around HANA. One of them is a product to actually do analytics on sports, and was used by the German soccer team. And as you know, German soccer team beat Argentina in the final. So I'm not happy about that, but it seems to be a very good product. So yeah, that's for you to know that there are many products around this technology, and there are going to be even more. The business suite itself is being pushed to use SAP HANA, so there are not going to be any other databases around the SAP Business Suite itself, which right now is being implemented on top of Oracle, DB2, Sybase and MaxDB, which are SAP databases, SQL Server as well. Well, everything is being pushed towards the direction of implementing all these SAP solutions on top of HANA. So main vendors, I told you about Oracle is releasing Oracle 12c. It's something very new. Also, MS SQL Server is releasing Hackathon within the SQL Server 2014. Then we have DB2 for Linux, Unix, and Windows. Also is including this in-memory technology. So we are going to see all these advantages in the upcoming versions. But then there is SAP HANA, which we are going to focus on for this talk. So we're going to see several different techniques that are kind of interesting for this blended technology. But if you want to take a look at all the vendors, right? So all the different options that you have for in-memory databases, you will see this is the Wikipedia. There's a whole list of them. It's quite interesting. I wasn't expecting such a big list. It is quite big. There are products from long time ago. The difference that we have now is that we have vendors supporting enterprise class products for these in-memory technologies. So we are going to see this technology implemented in companies. So what's different from this from this SAP HANA architecture of the traditional approach? Well, first of all, we need to understand what SAP is. Many of you raised your hand, so I understand that many of you know what SAP is. For those of you who don't know, just for you to get a picture of what SAP is, It's a software provider. It's kind of the biggest software provider for business enterprise applications. We're talking about ERP, CRM, GRC, Solution Manager, BW, Business Intelligence, all those processes that are being supported within a company, like releasing a purchase order, creating a vendor, paying, putting a bank account number into a vendor, managing all the stocks. There are a lot of different business processes that are actually being supported by these products. And what's important for this is that as HANA is SAP's star product, we are seeing HANA in many customers, and we are going to see many more customers implementing HANA because this is the new technology coming from SAP, and SAP is going to implement every solution on top of that. So it's something that it's a trend. Right now we are seeing a lot of customers, and we are going to see many more within the upcoming years. So yeah, just for you to get an idea of why we present in many IT security conferences, in many SAP security conferences, and we always show this message that we are talking about these systems that are not just a traditional web application, not just a traditional web server database. We are talking about systems that are actually running business processes, right? So an attack to any of these systems would not be basically a script kiddie having an ID 0 or someone being so powerful to run an exploit, right? Who's going to target these systems is someone who's trying to do an espionage attack, a competitor trying to get formulas from our systems, our customers, our providers, our processes, sabotage, someone potentially also a competitor shutting down our systems. And we're talking about business processes. A minute, an hour of these systems being down could cost millions to the company. And of course, fraud, like modifying bank account numbers, credit card numbers, creating an fake employee, modifying the bank account of a vendor. Well, there are different attacks that could be performed just because we have this information running on these systems. So let's talk about SAP HANA. This is schematics of SAP HANA, at least the architecture. But I think what's most important of this part is to understand that there is something embedded into the architecture that is a web server. It's called XS application. It's an HTTP server, and applications are being developed on top of that. So within the whole database itself, there is an HTTP interface that is providing web services and web applications to connect and interact with the database. So yeah, it's a fully memory database. You have the HTTP server. There are different deployment options. Back there in 2011, 2012, we used to see HANA as integrated, not as a full database for the business suite, but as an accelerator. Right now, we are seeing in different deployment options, we are seeing this supporting the business processes and accelerating BI, BW, and all the rest of the business processes as well. It has massive memory requirements. We're talking about the smallest version that we can run. It takes 32 gigabytes of memory just to start running. But then if you have a big solution on top of it, you need memory to move the tables from the disk to the memory itself. So if you have huge tables, you will have huge memory requirements. We are talking about probably terabytes of memory. So a blended architecture, right? So this is how it works for all the web frameworks that we used to develop on, like ASP.NET, PHP, Django, any other web framework that we used to develop on top of used to work this way. So we have the web application users that are connecting to the web application. Then within the web application code, something happens and there is a connection to the database, which is performed through a single user, right? There is a single user with full access to the database that is actually connecting to the database and accessing to the information. And then within the database itself, we have an operating system user that is the one that is running the database engine, right? So we have kind of 3 layers, different layers. So if there is a SQL injection, for example, here, it will be executed on the as the database user, so under those privileges. However, within SAP HANA, we have this blended architecture. So we have SAP HANA web application server, and we have the SAP HANA database all embedded into a single architecture. And what happens there is that we have a unique set of users. We have users that are database users, but are also web application users. So when you create an application, you just need to provide access to different users to that application, but those users could also be connecting to the database directly, depending on the privileges of the user, right? So that's where the blended architecture is. And because of this blended architecture, we have some things that could change specifically for the different vulnerabilities. The impact could be different, right? So in typical web apps, an SQL injection could access the whole database, right? Because we know that there is a parameter coming from the user. It's going to be used to create a SQL query, and that query is going to be executed under this unique user that is being used to connect to the database. However, when we are talking about SAP HANA web apps, the same user that is connecting to the application, to the web application, is the user that is connecting to the database. So the impact of an SQL injection, for example, is going to be different. Actually, it could be lower, right? Because if we have a good segregation of duties within the application users, the web application users, and if we restrict the access to only the tables they need to access, then the impact is going to be completely different. It's going to be less, right? It's going to be not as high as in typical web apps. However, we see that cross-site scripting is different, because in typical web apps, we have cross-site scripting that really depends on the user and the attack and how the cross-site, how you can exploit it. But in SAP HANA web apps, we have the IDE or the development environment, and we have applications that are developed, that are shipped by default, that could make cross-site scripting attacks even more critical, because you can, using a cross-site scripting attack, you can create a web application, for example. You can create a new page and just provide a web shell, for example. So that's something you can do. It's going to be restricted actually, because the interaction with the OS is limited, but you can provide an interface, for example, to execute SQL queries. So something that changes also is that the code is stored in the file system if we talk about traditional web applications. However, for HANA, it's stored in database. So again, if we have proper privileges, we could actually modify the web application on real time, do an insert on a specific web page, and make it behave completely different from it was designed to do, right? Then it really depends. The last point really depends on the framework, on how the application was developed. But it would be possible to actually interact with the operating system, execute commands, both at the database and at the web application level. However, for HANA, it is restricted, so it's nearly impossible to execute commands at the operating system level, because it's restricted on the interface between the HANA and the operating system. There are some libraries that could be used in order to get command execution, but that would be basically a vulnerability in HANA, right? So by default, there is no interface to interact with the operating system. So it's restricted. So if we think about that, everything is executed in the context of the database, of the HANA database. So it's more secure in that sense. It's way more secure because if we do a proper segregation of privileges, we have a good and secure application. So let me show you some of the programming languages just for you to know which is the scope of SAP HANA applications. You have XSJS, which is server-side JavaScript that's used to create applications, web applications. We're going to be interacting with that. Then there is SQL and SQL script, also to develop procedures within the database itself. R code. Have you ever heard about R programming language? Okay, some of you know it. It's a specific programming language that is used to perform statistical analysis. SAP HANA is very focused on processing information, on doing business intelligence, big data, data warehousing, processing all the different information and generating reports. So there are libraries and this interface, for example, with R programming language is also in that direction, right? To be able to process a lot of information and to generate statistics around it. ABAP also, if we have a business suite on top of HANA, and HTML5 because it's ready to develop mobile applications as well. So you have a broad set of different programming languages that you can use in order to generate applications around HANA. And SAP is pushing towards this direction a lot. So as for the development environment, I'm going to be quick on this, but this is the most important part because we have an IDE development environment which is web. So we can access through this HTTP port, we can access a development environment, create an application, modify an application, do anything our permissions allows us to do. So if there is an attack, for example, a cross-site scripting attack, and we can target a high-privileged user, we could, as an attacker, we could leverage this vulnerability to create a new web application, for example, doing anything the attacker wants. So that's kind of the most important part of this slide. I don't want to take many time for this. Then just, I think this is great for this product, is that how do you do to connect to any database? You just have the library, JDBC, ODBC, interact with the proper protocol to the database, Oracle with the listener, DB2, any other database, SQL Server as well. Well, SAP published all the documentation around the protocol that is being used for HANA. So you can have the packets, you can know the fields, you can know the columns, you can know everything that's going through the wire. And that's great because anyone can actually test the security of the protocol. So I have not heard about any vulnerabilities to the protocol so far. Regardless, there is public information about the protocol. So this makes us think that the protocol itself is very robust. And that's because there is documentation, there's probably processes in place in order to develop this. So threat vectors. SQL injection, how is SQL injection handled within SAP HANA and within typical web applications? Well, in typical web applications, we have a connection to a database using a single user. It really depends. It could be in the configuration or in the code itself. However, with HANA, there is a call to db.getConnection. That's a connection to the database with the current privileges of the user. And that's a potential SQL injection, for example. And that could be, what's important of this part is to understand that the impact are according to the privileges of the user, right? It's going to be depending mainly on that. So I'm going to show you a quick video. of how an SQL injection works in HANA. This is a test application that we have developed for you to see. So if you provide the parameter properly, it's you will see the information. If you insert an SQL injection attack, you will see that you will be able to see information. However, now we can make a union against another database which is holding the version of the HANA database. So using that technique that is on the end of the presentation, you will see you have all the cheat sheet. Okay. Having that union against the proper table, you can have information appended. You can have the version. You can have a lot of information that is going to be by the end of the presentation altogether. But something that is also interesting, I don't know if you remember this picture. It's from a very famous movie. It's called Back to the Future, right? And actually, this time travel term is not something invented by us. This is actually the feature provided by SAP HANA. It's called time travel queries, right? So there are some tables that are versioned within the database. So you have a current status of the table, so you have certain rows, but all the historical information is also stored within HANA. So this, what happens with this is that if there is an SQL injection, for example, information could be retrieved depending on how the SQL injection is being triggered. So just a little bit of a background on these historical tables. There are historical tables that can be configured within SAP HANA. The idea is that everything is stored within the table. There is no delete. There is no update, actually. Every change to a table is a new record. So as you can see, valid from and valid to are basically defining whether the row is valid at this point or not. If in the valid to there is a question mark, then the row is still valid. Sorry. Within the table itself, you won't see dates. You will see commit IDs, but this is better to understand with the dates, actually. And as you go and as you start working with the table, you will have new rows and new information, but nothing will be actually deleted from the table. And this is also interesting. There is a specific SQL query that you need to execute in order to delete the information from the table. And even though if you execute that, you still have to check whether the information is there or not. But if you define the table as historical table, then you definitely have a need for having all the information in the table, right? So these are the commands that could be useful in order to understand historical tables. To create a historical table, create history column table and the table name and then all the columns definition. But what's key there is history column table. Then to list the history tables, if you get in touch with a SAP HANA system, and you need to identify which are the tables that are defined as historical, that's a query. To access the historical information, select something from table as of commit ID and the commit ID. That you specify which is the status of the table that you are querying against, right? You want to know which, you want to work with a specific status of the table, which is defined by the commit ID. And then another way is to select start from table with parameters, request flags, all rows. That's going to return all rows. That's the SQL sentence. And to delete the historical information, merge history delta of table. I haven't tried that, but that should work. So let's see a demo of the historical SQL injection. So I have a text file with all the commands and all the information to avoid typing it. So we are connecting to an SAP system, an SAP HANA system. It's configured in that IP address 0.56, and the port is 8000. That's the interface you get when you connect to the slash part, right? No service. But then we are connecting to the IDE, which is /SAP HANA XS IDE. This is the interface. We go to the catalog because we want to see which are the historical tables, right? So this is one way we have to list all the historical tables is through this interface. It takes some time. Actually, these are videos because HANA systems, you can imagine that there's no way for me to run a HANA system on the laptop, so it's all videos. Then the user is actually running that query that you have in the presentation, and there is a table called accounts that's coming from as a result of listing all the historical tables. If we go to the editor, go to SAP, HANA, XS, IDE, and there is a package on AppSys. We have some test applications there, and there is one which is vulnerable to SQL injection. So there's the typical get DB connection, then we get the parameter, and we put the parameter together with the SQL query, so that then we list all the results. So if we interact with that application, that's what we're going to do now, we will see, that's the application URL, we will see how this behaves. So if we don't provide anything, it's going to give us an error. If we define an ID, we will get the results of that. So ID 1, we have the value of that record. If we want to access ID 2, it's a different record. If we want to access all the contents of the table, also exploiting SQL injection, we will have only 2 results. And this is because we are querying the current status of the table. But if the application is vulnerable to SQL injection, it should be possible to get all the contents, right? So it's completely different, the behavior, if you put just 1 equal to 1, that if you provide also the parameter to query all the rows. So that's the modifier that you need to use, or the parameter that you need to use is all rows. And just to validate the contents of the table, with using the all rows, we can see the valid from and valid to in terms of commit IDs. So that's, if you query without any modifier, you will have only those 2 records that we saw at the beginning. Okay, so let's go back to the presentation. That's how SQL injection together with historical tables could provide additional information if we need to analyze a web application running on HANA. So countermeasures, this is on the presentation. Use prepare statement, that's definitely a must. Also, do not put together strings, validate the parameters. So all the typical countermeasures that we already know from web applications, we need to use them here as well. And there is another one, which is the impact of all these attacks are going to be directly depending on the privileges of the user that is connecting to a web application. So we need to make sure that the privileges are properly set. Okay, so let's see some more threats. Cross-site scripting are complex as well. Depending on the vulnerability itself, are the type of things that could be performed. So this is just an example. If we get a cross-site scripting vulnerability and we target a high-privileged user, well, then this, for example, this piece of code could create a new application, right? So this could be possible depending on the privileges of the user. So that's why it's very critical. If we put together the ability to create new functionality with the cross-site scripting and the privileges of the user, then we have complex situations. Then other things to keep in mind is that if we have access to actually execute SQL queries or SQL or trigger SQL code, then it would be possible, depending on the privileges, to modify the application itself. So an update to the sys repo active objects modifying the C data would basically modify completely the application. So depending on the privileges, again, it would be possible to do something like that. And if there is a sentence which is called eval, that's also something dangerous as well. Yeah, I have some demos for cross-site and XSJS, which are very simple itself. It's basically an execution of a cross-site and how an eval together with XSJS could lead to modify or execute code within the context of the database. However, I think the most interesting demos are the ones that we have for the next chapter because we have limited time. So some recommendations for this: typically use all the features provided by HANA. For example, cross-site request forgery protection. Cross-site scripting protections are shipped by default within HANA. However, there are ways to bypass these protections. So in the end, it's all about parameters and securing the input coming from the user, right? So even though there are protections within the framework, we still need to put our own validations and make sure that no one's coming through the parameters. Restrict privileges. Yeah, these are some recommendations for you to have in terms of securing web applications in HANA. And then we have the R integration, which is basically the ability to create an SQL procedure executing R code, right? So what's going to be executed within the procedure is some code which is not executed in the HANA itself, but in an R server. So this is how the architecture looks like. These are some things that could be dangerous for this integration. So our server must be installed in a separated host, so remote connections have to be enabled, right? It's not within the same host as the HANA. So this is exposed to the network. So we need to put some restrictions in place there. And also exposes high privileged functions. It's possible to remotely shut down the R server. So the interface with the R, with these procedures will be shut down. And also OS command execution will be possible. So depending on the privileges of the user, we could be doing something in the server that is running the R server. Then as for authentication and encryption, that's also something we need to take care of because there could be authentication. The authentication needs to be configured to a strong password, also a strong mechanism, also SSL or some encryption, because we don't know what kind of information is coming out of the SAP HANA. It could be sensitive information that we used to process in the R server, so we definitely need to configure SSL. So let's see some demos as for the integration with R. So this is the HANA system. We can go to the catalog and see within the system schema which are the procedures that are defined in the system. There are some procedures that are shipped by default for the different libraries, but then what we can see is that there is one procedure that is the definition. Yeah, the resolution. I apologize for this. The resolution is not very good. There is one procedure called my_f. If we open the definition, we will see that our code is being executed in that procedure, right? So it's defined as a procedure that is executing our code. Yeah, everything takes some time. We see the parameters, we see the definition, there it says something like rlang, which is basically an R procedure. So if we move, yeah, also it is possible to see within the HANA which is the IP address of the R server. So we can see which is the external IP address that the SAP HANA is connecting to calculate all the R code or to process all the R code. So what can happen is that if we execute the procedure, everything works normally. But if we connect to that IP address, which is in a different IP address than the HANA server, we can see the port that is open, which is 30120. That's the port that is configured within the configuration of the SAP HANA itself. And what can be used is something in Python. It's a package in Python called pyrserv. We can connect to the R server, and we will do that. We will import pyrserv, then connect to the R server and do something as complex as con.shutdown, and that will basically shut down the R server. So then any connection to the R server will be denied because the service itself is down, right? So if we trigger it, it's going to give us an error, which is connection denied. And the next one, as for R integration, is that there's also the ability to execute commands within the R server. So what the attacker could do also is not only connect directly to the R server, but modify the procedure. Because if the attacker doesn't have a direct connection to the R server, he knows that the SAP HANA itself has. So what the attacker does here is basically drops the procedure, creates a new one with some slightly different commands, which are, I will tell you which ones these are. It's net user, JP, that's my user, the password, /add. This is running on a Windows just because of the easiness to install R server and everything. But this, if it's R server connecting with HANA, it's going to be on Linux. Then it's including this to administrators group. And then whenever someone is actually triggering that procedure, those two commands are going to be executed. And I'm going to go to the end. He modifies the procedure. So then this procedure is executed, and he will see, this is the R server. He will see that the commands were completed successfully, that you can see there. And he will connect through terminal server to the system. That's the last part. Yeah, he will authenticate to the external server. So depending on how secure the integration is, it could be possible to compromise the external server to actually, it could be even worse depending on the type of information that is being sent to our server. The attacker could actually retrieve any information. It really depends on how the system are integrated, how the integration is configured. So you have a lot of information in the previous slides. Configure a firewall, use SSL, configure strong authentication with strong credentials, use low privileged accounts, all those recommendations that are definitely needed in order to secure the integration. And also restrict shutdown. I don't know if it's possible to restrict system the command execution, but if it's possible, it should be also performed. Then there are some libraries provided within SAP HANA by default. SAP HANA itself is built in C and C++ because of performance requirements. So there are some libraries which are actually doing analysis, like processing and computational processes that are developed in C, shipped by SAP itself. There are some of these are interesting because are interfaces between the web application, which is that URL, for example, and some library code in C or C++. So those are the interfaces between SAP HANA and C and C++, which are provided from SAP, and this is something that we have by default. Just information for you to keep. Also, pentester cheat sheet. These are all the different commands. If you are pen testers, this could be interesting if you are analyzing SAP HANA implementation, some information gathering, so how to read files, create a user, list the password hashes. Yeah, all sort of different commands that are useful. Also, you have the time travel SQL injection commands as well in a previous slide. So let's draw some conclusions. We are talking about in-memory systems that are used to support our business critical processes, right? So we are talking about ERP, CRM. We are talking about very important systems for our company that are using this technology. So with this new paradigm, we need to understand how to secure the system, how to secure the application, what's the impact of the vulnerabilities, because it's going to be different depending on the user, depending on the exposure of the applications. So there are different factors, but we need to understand each one of them in order to properly define which is the criticality of an issue, which is the urgency, how fast should we fix, or how fast should we modify something. SAP HANA was built with a security focus, so we have been in touch with SAP HANA systems. We know that these systems are very secure by default, which is something that in the past SAP systems used to have it differently. Many insecure configurations by default. This was changing through the years, so now we have a different picture. But there are things that are not in the space of the vendor, but in the space of the administrator, of the developer, of the end user. So we need to be aware of all these threats in order to know which are the set of threats that are affecting our implementations. And then there is 120 pages of HANA security guide. If you are interested in that, I recommend you to read it and also follow the recommendations that we provided through the presentation. Finally, some questions. If you have any, this is the time for them. I apologize for my English. It's not the best, but if you need me to clarify something, I can go back and go over anything. Okay, then thank you all for attending.